Hello, everyone. How's everybody? Welcome to Rational Science. But today we're not in Germany. I'm in South America on vacation, and we're going to have to do it from over here. So I would appreciate anyone letting me know if you can't hear me or you can't see me or the transmission is choppy, okay? Please let me know. I'd really appreciate that. Meanwhile, I'll continue, and we're going to start with some of the subjects of related to extinction. Here we have a situation today that inflation is eating away at salaries, which is essentially what my theory. I'm saying that that's exactly what's going to happen. The salaries are going to become less valuable as time goes by, and at some point they're going to be worth less all the way to worthless. So I think that's what's going to happen. And here's a couple bit of news there. Okay, thank you. Here's a bit of news that came out of one article out there. You'll see several out there, so I haven't mentioned where this came from, but it says inflation, now running at 6.2 per year, has quickly become the dominant economic trend. Okay? Biden said over the summer that a spurt of inflation was likely to be temporary, stemming from the COVID pandemic. 4 months later, inflation is getting what? Worse. Okay? Now, they might fix that temporarily, but I'm saying that this is going to be a trend, a long term trend, where the worker, the salaried person, is going to be getting less and less for his work. And that's not really a big problem. It doesn't really matter if he gets less for his work. The question is whether he can make it to the end of the month. And it says there's not a lot Biden can do about it. Okay, root causes: semiconductor shortage, massive new spending on goods as consumers stay home, and a dearth of truckers to move goods out of ports towards their destinations. Consumer confidence index, the lowest level in 10 years. Lingering COVID could be part of the gloom. There are still near record 10.4 million open jobs, and workers are quitting at record rates. A sign that they have better opportunities elsewhere, like at home doing maybe YouTube stuff. Everybody wants to set up a little shop where he receives a check every month for ads or whatever. Okay, and so we have a problem because you have all these all these job openings, and nobody's going into them. The job market remains white hot, leaving inflation as the only real skunk at the party. Fiscal spending probably isn't the main cause of inflation, but if it's flooding the economy with money and pushing up demand for scarce goods, it could at least be contributing. So, yeah, the question is whether another round of handouts from the government, will that just fuel inflation? I mean, it might solve a lot of people's problems, especially the poor people, but will that just create a new round of inflation, of devaluation of your value of your salary? And I think that's the bottom line. So one of the things to think about is that that's what I'm saying that's going to happen. The economy is going to collapse because money will be no more. Why will money will be no more? Because over time you're going to have a devaluation of money to the point where the worker doesn't make it to the end of the month. Okay, and at that point everybody's going to come out. They're going to break windows. They're going to light fires on tires and whatever. There's going to be a big mess out there. That's what I think is going to happen. And parallel to that, you got something else going on, and that's the war between, it's a Cold War now, between Russia and the United States and China and the United States. The United States being the big empire, trying to expand its influence in regions where it's meeting up with these two other giants. Okay, one is in Ukraine. That's the map up there. Ukraine essentially owns the western half, and Russia owns a little less than what I showed there, but The other region that is there, a lot of Russians live there, and they are pro-Russian. They are not pro-Ukrainians. So that more or less gives you an idea how the map of Ukraine is divided. And the important part there is that little island on the lower right, that's the Crimea, and there was a big war in the 1850s over there. Russians fought against the Turks, British and the French, who were on the side of the Turks at the time. But irrespective of what happened those days, Crimea has belonged to the Soviet Union. When the Soviet Union broke up, it went to Ukraine, hoping that Ukraine would stay within the orbit of Russia. That didn't happen very well. Ukraine, Poland, and some of these other countries want to be on the western side. And so Russia had no other choice but to take over what it considers a militarily strategic point, which is that little island there. That's where it's got its fleet. Okay, and on the bottom we see a little island there, right off the coast of China, and that's Taiwan. Okay, and China wants that little blue island, and maybe there's going to be a little bit of fighting over that island. The question is going to be whether it's going to be a little bit or a big bit. Okay, that's the question there. Is it going to stop at a conventional war, which is likely is going to lead to war, or will it go one step further and go into nuclear war? Okay. So I think these are the issues of today, and those are the ones that are probably going to take us to the end of the world. And it's going to be inflation, the fact that the workers are going to be losing real value in their salaries. They won't make it to the end of the month, and at some point it's not even going to be worth going to work. And on the other, you have these military confrontations, Cold War. Taiwan, maybe one of them. I don't know if a third one will appear, but right now it looks like it's Ukraine and Taiwan. So keep those two regions in your head. I think they're going to have a big impact on the future of not only man, but on your personal future. Okay, things on the other side of the planet might influence your own life. Okay. Okay, some of the issues people brought up, primarily related to homosexuality. Apparently, it's a subject that a lot of people are talking about these days because we see a lot of it. Suddenly, it came out of the closet, so to speak. It's popular, it's out there, and people have opinions about it, strong opinions, by the way. Okay, here's a couple opinions. Okay, one fellow says there's a correlation between mother's diet, he suggests vegetarian, and the probable gender of their child. Yeah, I guess if you eat more veggies, you get a female. Perhaps the mother's diet also affects sexuality, gender identity. Okay, it's interesting opinion. Could it be? Is it possible that what we eat determines not only what kind of kid you're going to have, but also the orientation of that kid? Is this something related to the environment, to what we eat? What is it related to, all this homosexuality? Has there always been homosexuality all around us and we just suppressed it and kept it inside the closet? Is that what's happened? Or is there something new going on where suddenly you have more and more people who are coming out of the wombs as homosexual? I think that's the issue. So again, it's the issue of nature versus nurture. Okay. One fellow says, along the same line, most gays are in prison and are environmentally gay. Well, I don't know about that. I think this fellow knows very little about prison and even less about homosexuality. In prison, you don't see gays. Very few gays. And the first thing they do is look for cover. They look for protection. A lot of people want to kill them in prison. And most people, not most people want to kill them, but most people, I'd say half and half. Half of them tolerate them and half of them have problems with them. Okay, they don't like them. And gays know that. So what they do, they try to ask for some kind of protection. That's one issue. The other issue is that they don't do it openly. Okay, they don't sell their wares out there, so to speak. Okay, and yeah, we had a few in our prison, and they went around. One guy even slept with another, asked to be sleeping with him in one of the rooms, and they let him, and they did their thing in there. Most of them didn't care. Most people didn't care. But I had an anecdote where one guy wanted to kill one of these guys simply because he was homosexual. So no, no, most people in prison are not gay. In fact, I would say the opposite. Most homosexual people never make it to prison. In fact, today I think, if you ask me at least, I'd say the world is turned upside down. A lot of rich people are gay. Go to San Francisco. I used to live there in Sunnyvale. And you go to San Francisco, a lot of people are rich there and they are homosexual. That's like the homosexual capital, or at least used to be homosexual capital of the world. And a lot of people live there that are rich and they are homosexual. So I don't know about this going to prison. No. And another thing, I like to mention to people, people think that, you get to prison the first day you get raped and they say, "Oh, I'm going to get gang raped." In fact, they made a movie about that. But that's all nonsense. That's all, I think, government propaganda so that you behave because you'll be raped the first day you go to prison, No, it doesn't happen. Quite the contrary. In fact, just imagine there's a little gang in there. There are a bunch of gangs, by the way. You think the head of the gang would tell his buddies, "Hey, here comes a new inmate. I think I'm going to rape him." What do you think his buddies would think of him? You think they would say, "Oh, that's our leader"? No, they would wonder a lot about him. No, it's the other way around. It's a macho world over there. It's all alpha people, more or less, in there. You don't find homosexuals in there. And the few that are there, they take care of themselves because they could be in trouble with who knows who. Someone might approach them, just punch them in the nose, you know. Okay, another fellow says same-sex relationships can have biological children of their own through such things as artificial insemination or surrogate mothers. A heterosexual couple isn't a requirement to have children. Well, yeah, of course we all know that, but the issue is you need a man and a woman. You need an egg and a sperm. And you don't get egg and sperm from two guys. You don't get egg and sperm from two women. That's the point. Okay, so yeah, they have to go outside of the matrimony, of the partnership, whatever you want to call it, in order to have kids or adopt. But they won't be able to have. Two women can't have children. Two men can't have children. And so the question is, I throw this question to you: if we have more and more homosexuality on the planet, let us assume it's increasing, right? If it increases, that's a way of stopping reproduction, because the only way they're going to reproduce is by getting to the other sex momentarily, going to a sperm bank, whatever, right? But even in that case, do you think a homosexual couple, whether a female or a male, will decide to have 10 children? So one of the issues there is whether maybe Mother Nature instituted homosexuality at the end of a species' lifetime to stop reproduction. Is that a mechanism Mother Nature has in store? In other words, is it deterministic? Or is it, like a lot of these people think, that it's something environmental, something that you eat, free will? Is it? Are you born that way, or are you nurtured that way? Nature versus nurture. Are you born that way? Are you born heterosexual? Or did someone train you to be it? They educated you and say, you got to look at girls. You can't look at guys. Is that the way it works? Or was it something like innate? It's something inside you. So these are the things you got to ponder. whatever applies to you applies to the homosexual. So if you were born heterosexual, you're attracted by women, or male attracted by women, and vice versa, right? You got to think of homosexual in the same way. These guys are just attracted to a female by nature. It's just inside them. They can't do anything about them. At least that's the way I look at it. I don't think these people were educated to be like that. And to answer some of these questions that come up here, I'll answer them in a second here. Why do people stop being gay, though? Most change their orientation within 13 years. The ex-gay phenomenon is very real. I know for merely gay men who suddenly stopped and started pursuing women and heteropornography. Okay? People usually just say, oh, they're secretly gay, which is a code. It doesn't help that we can't step into these people's shoes. And along the same lines, a fellow says lots of people get out of their hormones. In other words, they go from being a homosexual to, I don't know, to a gorilla. Suddenly he's got this Tarzan stuff in him. I don't think so. I don't believe that a gay man can change any more than you can change being heterosexual. If you're heterosexual, do you think tomorrow you're going to say, well, today I think I'm going to try same sex? Do you think it works that way? I mean, that you're actually, truly, genuinely attracted by your same sex. Do you think that changes overnight, that you just slept and had a bad dream or something, you wake up and say, hey, I think I'm going to go after my same kind? You think it works that way? I mean, do you want to do that? Would you desire to do that? And then the question for the gay man is the same thing. He says, first, do you think he really changed? I mean, assuming he tells you he changed. Most don't even tell you that. But the question is, do you even think he wants to change? I mean, do you really think that? He's got it inside him. He can't do anything about it. It's like he's attracted to a guy instead of a female because he's got, again, like a female brain. And that's all I can tell you. I mean, I'm not an expert on that. All I can tell you is what I've read out there, and that's that the brains of homosexuals have been, they cut them up and they studied the certain sizes where love is produced inside the brain. They found them to be very similar to females, not to males. So, I don't know. That's a factor you got to research if you're interested in the subject. Okay, almost there, same sort of issue. Men do overrate their own masculinity. Look into a book called Men Against Fire by Mr. Marshall. Over 3/4 of the soldiers in World War II refused to fire at the enemy, even when under direct threat of death. Well, first of all, I don't know if that's true. I'm not sure if Mr. Marshall counted all the soldiers there, and said, yeah, 3/4, 75% decided not to shoot. Then I don't know if this is related to macho culture, the fact that males in general did the war through most of history. Right? Yeah, that's true. And does that have anything to do with homosexuality or lesbianism? Does it have anything to do with more testosterone, more estrogen? Does it have anything to do with that? Or is this just an issue of tradition of, again, free will, not determinism, but free will? The fact that a lot of these people, they're sent into a war zone and now they have to shoot at the enemy. And to say that, first of all, that they're macho because they're there, I don't know. The second one is, the guy has to shoot at someone coming down. Well, it's either him or it's either him or me. It's, what do you think he's going to do? And I'm not sure about these people 3/4 not shooting. I don't believe that either. I think if that were true, nobody would die in the war. Okay, very few would die. No, I think people shoot. They're told to shoot. They told them that's the enemy. Here, the enemy is rushing towards your bunker or whatever, what are you going to do? You're going to say, no, I'm not going to shoot him because he's a human being. No, you're going to shoot him down. That's what you're going to do. Just, a knee jerk sort of thing. Okay, another fellow says, well, it is known that girl gymnasts start their menstrual cycle later than other girls. Okay? So being physically strenuous has something to do with lowering estrogen. Okay, here all I can tell you, I looked at 3 articles. These are 3 statements from 3 different articles. Okay, and one says there were no significant pubertal increase of estrogen levels in female gymnasts during their peripubertal development, indicating a low amount of fat mass in female elite gymnasts. Another one says the present study found no significant difference in resting testosterone levels between the gymnasts and the controls, despite the large amount of training these gymnasts were involved in. And then third one says women who are elite athletes or who exercise excessively on a regular basis are at a risk of developing athletic amenorrhea. Causes are thought to include low levels of body fat and the effects of exercise-related hormones on the menstrual cycle. Okay, so whether they really have more estrogen, less estrogen, I'm not sure. That's the case, but again, it comes down to what people believe, not so much what is objective. And so all I can do is tell you to do quite a bit of research and don't hang on to whatever confirms your theories. Try to find someone who has made a study against your theory, so that you have something to compare against, someone that you can fight against, and not be so comfy with your own beliefs. Okay, let's move on to the second segment. We're going to do a little bit of physics here, and I'm going to start with a recap. Okay, here it is. We've been doing distance, we've been doing force, mass, acceleration. And the first thing I want to mention, just reinforce that, is that the distance of physics, separation, is not the same thing as the distance traveled of mathematics. Very, very important to keep that in mind. Mathematics only has distance traveled. What they do, they unroll the measuring tape and they measure how many meters, how many yards, how many kilometers, miles, whatever. So distance, when the mathematician says distance, he means distance traveled, displacement, movement, change of position, of location, whatever. There's motion. Okay, that's not the distance of physics, which is a static concept, which is a separation between 2 objects. Distance traveled is one object that moves away from a given an arbitrary starting point. Force in Newton's second law, right? Force equals mass times acceleration. That's push. Okay. Again, you're parting from a point and moving forward. Okay. And what is that? Mass times the acceleration. You're pushing. Okay. And it's a dynamic concept. On the other hand, Newton's gravitational law, those 2 laws, by the way, were ascribed to Newton, even though he doesn't deserve the first one more or less. The second one, again, more or less. He didn't come up with a gravitational constant G. He just said, it's because of masses that we're being attracted. That's all he said. It's a description. He never had an explanation. And so the second equation there, force equals gravitational constant G, mass 1, mass 2 over distance squared. That's a pull force, okay? And that's a static concept. Actually, it's not pull, it's a tension, because what you're talking about is 2 masses, mass 1, mass 2, separated by a given distance. That's all you're talking about there. And so that separation of the 2 masses is what gives you the force at that location only. If that one of the 2 masses moves a gazillionth of an inch, all bets are off. Suddenly you have suddenly you have a different weight, which is a different force. Okay, that's an equation for weight essentially, because you're talking about gravity pulling down on some object. One mass in this case would be the Earth. The other mass, mass two, could be anything else. Could be even the moon, for all we know. So whenever you're talking about this equation, you're talking about two objects and separated by a given gap, separation. Okay, and so that equation really is an equation of tension. I'm saying what you have there is tension, not force. And tension, no, it is not a force, as the mathematicians have always said for the last 400 years. Tension, nobody wins the tug of war. Force, you have only two forces, push and pull. In quantum mechanics, they invented two more, the strong force and the weak force. We don't know what those are, but they seem to be very similar to push and pull, because the weak force is an outward force, and the gluon, the strong force, is an attracting force. It keeps two quarks together. So again, we have push and pull. So the mathematicians have not invented anything whatsoever under the sun. We still have qualitatively only two forces, push and pull. That's it. There's no more. Tension is neither. Tension means that you stretch the rubber band to the maximum. It doesn't stretch anymore no matter what you do. So essentially at that point you can treat it as an object made of a single piece. Okay? Let me repeat that. You stretch it so much that it's almost an object made of a single piece. And at that point you have no motion whatsoever. There is no motion. The two objects are just static. They're sitting there waiting for something to happen. Okay, so tension, no motion. It's a static concept. That's why it doesn't fall under force, which is a dynamic concept. It means something moved one way or the other, push or pull. I hope we got that, okay? Because the mathematicians out there, they say, no, but we studied and we memorized the stuff in college at the monastery. Yeah, sorry. Qualitatively, no. We have a difference between tension and pull, first of all, and tension and force, because force is what? An influence that can change the motion. And that's not what tension does. Tension doesn't change the motion. That's what it doesn't do, okay? It's what? An action-reaction pair of forces. But they talk about forces, again, this definition is the one you get in the dictionaries, okay? Conceptually, from a physical point of view, tension is a tied game. No one wins the tug of war. Everybody's pulling, and at that point, at some point, you stretch it to the limit, and that's tension. You're in a static situation. You have a certain distance, separation between the two objects, measured by, you can say, well, that separation is a synonym of the maximum stretching of the rubber band, string, rope, whatever you got in between them, wire, coaxial. Okay, and then we went into mass, okay? Mathematics, what do we have? Mass is equal to weight. There is no difference in mathematics between mass and weight, because they never found a way of distinguishing between them. The way we determine mass is by weighing. We don't count atoms. See, if we counted atoms, you could say, well, mass is the quantity of matter, and weight is what we get on the, once we put it on the scale. That's not the case. We put mass on the scale. That's how we determine mass. That's why it's measured in kilograms. Supposedly weight is measured in newtons, but nobody talks about newtons. Everybody talks about mass, kilograms, weight, kilograms, or pounds, bushels, whatever. It depends on, what unit you want to use. And unfortunately, there's like 7 definitions of mass in mathematics, and they just live with them and continue on as if nothing. And I showed the other day there's like 4 definitions of weight. Again, everybody just uses these things. They say we haven't agreed. Who cares if you agree? I mean, this is a question of science. In science, we do not agree. We fight for our definitions, and not everybody can have the same definition. Okay? If you have your definition, you have to defend it against attacks. That's the way it works. There is no consensus, no democracy, no authority in science. Okay, one person says, no, I'm sorry, this is, again, well, yeah, this is what one person says. He says, you don't understand weight. Oh, okay. Educate me. Let's see. He says objects don't have weight in free fall. They only have weight on contact, meaning, if it hits a scale, then it has a weight according to this fellow. That's what he learned at the monastery. Mass is a detached approximation for weight. Okay, let's find out. Let's see if this fellow is right, okay? Is even in the ballpark, okay? Here we have. Weight is location specific, okay? Location and weight are static concepts. You have weight for a given location only. You have a different weight in a different location. You have a given weight for a given location only. Weight does not require contact, which is what this fellow is arguing here. Okay? Measurement is not an activity of science. Science, we don't measure anything, therefore there has to be no contact. We don't use our hands or elbows or head or our body to contact something. No, we use our brain. We use our mind, okay? In science, we do not place the astronaut on a scale to determine whether he has weight. In science, we conceptualize weight. The astronaut has weight whether we weigh him or not. Okay? Do you think that astronaut on the lower right there, do you think he has weight at a given distance from the Earth? Well, yeah, he has weight. Is it because we put a scale underneath him and he has contact with a scale and he pushes down on that and says, okay, you weigh 100 pounds here and you weigh 50 pounds over here and 150 over there? No, we don't do that. We don't have to do that. We know he has weight at that location. He has a different weight at a different location. We don't have to know the value in science. There are no observers in science. Okay, and here we show this gentleman that no, we do not have need contact at all. Here it is. Here's the weight of the moon. It's 7.35, 10 to the 22 kilograms. That's how much the moon weighs. Is it because we put the moon on a scale somehow? Is that how we determine that it weighs that many kilograms? I don't know if you can find a scale that big enough, and I'm not sure what kind of contact you used to figure out, what the moon weighs. No, this was a calculated value, okay? And so we do not have to have contact with the moon at all, okay? And in fact, if the moon moves a little bit, here you see it, okay? You can see that since the Earth is first of all, not a completely round sphere. It's an oblate. Okay, it's a spheroid, and it does change its shape as the moon rolls around it, as Mr. Newton discovered. Okay, so that's something we owe Mr. Newton. But you can see that the moon weighs differently as soon as it moves just an inch around the Earth. Okay, so the moon doesn't always have the same weight. Okay, the way they should really do that, if they could, is give different weights for different locations. And they could probably do that with the laser pointer, the laser, the laser ranging experiment that they have out there, because they can gauge the distance from the moon to the Earth, and that can give them a good clue of what the moon weighs at different locations. They need that distance, okay? Okay, so today we're going to do work. What is work? Okay, anybody have any idea what work is out there? Well, I'll tell you what work is. Here it is. That's my definition. What the new generations don't have. Now, how's that for a definition? I guess that's got to do with extinction, not with physics. Okay, and here you have another one, which I have, what the new generations won't have. How's that for a definition for work? And how about this one? This is a better one, maybe. What the new generations don't want to do. I mean, how many people they say, they have 10 million jobs and nobody's applying for them? That gives you a clue that there is work out there, but either it's not well paid, people are thinking that it's not worth their trouble. Maybe the guy lives with his mother or his folks, and he's toughing it out, maybe, I don't know, selling something on the streets or whatever, or maybe on the internet. And so he doesn't want a job that's going to take up all of his time, especially. So he says, look, I value my time, what am I going to get extra if I actually go out there, work, and get a salary, a devalued salary, right? Is that worth my while? Or should I just continue doing what I'm doing now, whatever it is, right? And live at mama's or at my girlfriend's or whatever, and, just live along. I think a lot of people in the new generation are selecting that option, right? They're going with that option. Okay, but let's see what it is in physics. Okay, it says work, force times the distance through which it acts. Okay, so we have a force, and it's going to be applied through a certain distance. And there you have the one from dictionary.com, says the transference of energy equal to the product of the component of a force that acts in the direction of the motion of the point of application of the force and the distance through which the point of application moves. The transference of energy. We're going to be transferring energy, whatever that is. I guess we'll find out in a minute here. What does Wikipedia say? Well, work is the product of force and displacement. Okay, that's sounds straightforward. And then it continues. Work, the energy transferred to or from an object via the application of force along a displacement. Again, the energy transferred. Okay, so there you see all these energy thingies moving from right to left. Is that what work is? Just a bunch of concepts being transferred? I mean, what is this thing called energy? And again, I always like to introduce authority so that I can convince you and persuade you and convert you. Okay, and so here it is. We have Mr. Richard Feynman. He says, it is important to realize that in physics today, we have no knowledge of what energy is. And I can only tell Mr. Feynman that energy is not a what. Energy is a concept. What is it? The capacity, the ability, whatever. Okay, that's a concept. So you can't say you're going to transfer energy like these people are saying, or move energy around. You can't transfer concepts. So the first thing we note is that if work has something to do with the transferring of energy, we already start off on the wrong foot. This makes no sense whatsoever in science, okay? In physics. This has to do with mathematics, an explanation, a physical interpretation in which they're moving concepts. And that's our first notion of irrationality. Irrationality, first notion, or first criterion, movement of concepts. It's called reification. You are reifying a concept and then pretending, going through the motions, like the mime of moving it around. Very scary stuff, okay? Yeah, never do that. They might put you away. Okay, they should put all the mathematicians who do that away. Okay, you can't transfer energy because energy is a concept. And unless you have an object, you can transfer a tree, you can transfer a dog, you can even transfer a house, some of these prefabricated houses, but you can't transfer energy. You can't transfer love. You can't transfer intelligence. Some people apparently have, but in general, I mean. Okay, so what is work? Well, work is performed when a body is moved against a resisting force. Okay, so there you have the little man, he's pushing, and in this case, you have friction on the ground, maybe if that's a refrigerator, for example, right? It weighs a lot, so it's being pulled by gravity or pushed by gravity, whatever gravity is, right? But the point here is you got friction, and so the guy has to push against that friction, essentially, okay? And so work is force times distance traveled. And again, it's not distance, it's distance traveled. We're talking about displacement here, okay? There's motion. Okay, here we have a little breakdown of that. So we have work is equal to force times distance traveled. What is force? Well, we held that force is equal to mass times acceleration. Okay? But what is acceleration? Well, acceleration has this change in velocity over change in time. And we don't have to go into any more detail with that, just to say that change in velocity includes distance traveled. There is a distance traveled component in velocity. Okay? And what is that? That's motion. So we have work is equal to mass times motion, which is that portion of change in velocity. And what is the distance traveled that we started out with there? Force times distance traveled. Well, you see it's motion as well. So we have our conclusion. We have work is equal to the motion of motion. In fact, mass is also motion, because what is mass? It's not the counting of atoms. We don't do it that way. What we do is we weigh it. And the mathematicians would like for you to think of mass as a dynamic concept, because like in special relativity, if you accelerate mass at near the speed of light, you are pressing down on the scale a lot harder than if it's just standing still. So what happens is they say mass increases. So they have mass as a dynamic concept because it's moving near the speed of light, and so it increases, therefore it's also motion. So I forgot one motion there at the bottom. I would have to say that work is the motion of motion of motion. Okay? That's a more correct way of stating. So what do you do when you go to the office? What do you do when you go to the rock pile? Well, you are doing a lot of motion and nothing else. Okay, now you know. What is work? But a bunch of motion. Motion of motion of motion. That's it. Okay? But here we have another situation. What if we take that equation, okay, and now we turn it around and put it in a vertical direction? Well, what we have is work is weight times height. Remember, what is weight? That's force. What was force? Mass times acceleration. And what they always use that force equals times mass times acceleration. But now you're talking about weight. And what is weight? Weight is a struggle against gravity, especially if you're pulling the box upward, you're pulling against gravity. Or maybe gravity is pushing down on the box. Some people like to do it with particles, right? Okay? Either way, you're fighting against gravity. That's the point. Okay? You're struggling against gravity. What is height? Well, that's the distance traveled. That's the displacement. In this case, it's a vertical displacement. Okay? So we have work. In this case, it's no longer sideways like it was before, force equals mass times acceleration. Now we're supposed to use really Newton's gravitational law, right? You would think, because it's more applicable to what we're doing here. So we would have to use the force in the gravitational law, which is gravitational constant G, mass 1, mass 2, divided by distance squared, which is essentially the distance between the box and the center of the Earth. What is that times? Height. Because what is height? It's not a single value. What you're doing, you have a displacement upward. You're moving the box upwards. And so you're going to look at how much you moved it and say, okay, that's how much work I did. Okay, I hope that's clear. So we have two different types of work. We have one which is horizontal work and one which is vertical work. Okay? And what I'm saying to you is that I have no problem with them using the mass times acceleration force for horizontal movement, but we have a problem when they don't use that when they don't use the gravitational equation for upward or even downward, by the way, because going downwards just make it easier, but you still have the force of gravity, one way or the other. So when you do it vertically, in other words, perpendicular to a plane cutting the center of the Earth, well, when you do it vertically like that, you have to use Newton's gravitational law. That's my proposal. I'm saying the mathematicians never discovered that, and they keep using force equals mass times acceleration for everything. Okay? So why is that a problem? Well, let me show you. Here we have a different situation. We have an inclined plane. Okay? What happens in an inclined plane? Now we have two components. We have a horizontal component and a vertical component. Okay? Here you have a little more than maybe 45 degrees, more or less. But you can see what's happening here. You have a vertical component and a horizontal component. And now which equation are we supposed to use? I mean, we have force equals mass times acceleration. That's going to be for the horizontal segment. How about the vertical segment? Aren't we going to use the gravitational law? G, mass 1, mass 2, divided distance squared. Distance between what? Between, I guess, the ball and the center of the earth. Separation, okay, for any given point along that curve. Okay, that's what we're talking about. Remember, force, when you calculate for force, you're calculating only one value. That value is only valid for the given distance that you calculated. The next frame of the movie, okay, you have a different distance. Now you have to do the calculation all over again and calculate the force for the new distance, assuming the masses stay the same. I mean, we will assume the two masses are the same. The separation changes. Gravitational constant G is, again, a constant, so we don't change that. The only thing that's changing there is the distance, okay? But the distance is upwards. So you have separation between the earth and the ball, and you have different values for every single location, okay? So you take all these values and you can, get your curve in mathematics. Okay, so what's the issue here? Well, this is more or less the situation, okay? Here it is, all three of them put together. No, sorry, this is just the explanation here. Inclined plane, okay, work is equal to force times distance traveled, okay? But what happens with a slanted surface that has two components, the horizontal and the vertical? Well, the vertical part, you should be using Newton's gravitational law, okay? Work is equal to force times distance traveled times cosine A. Where did they get that? Well, the cosine A gives you the angle of that slant there, the slope of that curve. Assuming that mountain that the fellow is pushing the ball upwards onto, assuming that were a completely straight line, right? Well, you could calculate through the cosine of A what value to give at each point, okay? So what happens? When A is equal to 0, you have cosine of 0, and that's 1. And that would give you a horizontal. That's if the guy rolled the ball or pushed the ball sideways, horizontally. No upward motion. But what happens when you have it at an angle? Well, they don't use Newton's gravitational law. What they do is they say, well, calculate the angle, okay, and just get the cosine of that angle. It'll give you that slope, and that'll give you the work that you did if you multiply it times force times distance traveled. Okay, that's how they do it. That's conceptually what they're doing. But the issue is they're not taking into consideration the gravity. What they're doing is just calculating an angle because that's sufficient for mathematics. The question here is what is happening physically. That's what we want to understand. Okay, and what is happening physically is that you have two motions, a horizontal and a vertical one. If you did the vertical one alone, you would have to use Newton's equation. They don't do that. They use force times mass times acceleration. And then they get confused because you get people like Einstein. He says, I don't understand why force equals mass times acceleration is equal to force equals g mass 1 mass 2 divided by distance squared, which is essentially the principle of equivalence. And he says, well, I think they're very much similar, but I don't understand why. Of course he's not going to understand why because he never did qualitative stuff in his life. That's why he ended up with warp space and warp time and who knows what, in other words, fourth dimension. No, it's very simple. Under the rope model, I explained it the other day, you have a hydrogen atom, whether it's leaving the Earth or coming towards the Earth at a given distance. Force equals mass times acceleration, which is the push force going outwards, is equal to force equals gravitational constant G, mass 1, mass 2 over distance squared, which is the pull force of all the ropes at that given point, at that given distance or location. Okay, so here we have it, all three of them put together. Okay, we have the guy on the bottom. He's pushing his, I guess his refrigerator, pushing it sideways. Okay, that's work equals force times distance traveled. No problem there. We have a problem with the guy on the right because they use that same equation essentially, and they should be using the gravitational equation. That's what I'm saying. Again, versus distance traveled. And what do you do when you roll something in an inclined plane? Well, somehow we have to make use of these two equations and turn it into in order to understand physics, right? So that we would have to use a combination of these two equations to understand the physics of it. Instead, what they've done is they said, just calculate the angle, the cosine of A, and you'll be okay. You'll know what the work is. Yeah, that's great for mathematics. It doesn't give us any insight in physics. Okay, so that's, I guess, what you can say is the bottom line. We're interested in physics, not in math. Okay, here are the conclusions for today. Okay, we have Math Viz. These are their versions. Work is equal to force times distance traveled times cosine of A. Okay, work uses Newton's second law. Force equals mass times acceleration. Work does not incorporate the law of gravity. Okay, and essentially it amounts to what is it? Push times motion times motion. What is push? Also motion. So it's motion times motion times motion. That's what work is. In science, we do it a little differently. That was the mathematical version, okay? Science, we do it a little differently. We say, in physics, there is a gravitational component, okay? So that you understand that you're pulling against gravity no matter what. Even if you go horizontally, you have to factor that gravitational pull. They never do it because it's the same for anywhere on Earth, essentially, right? So, you look at only the horizontal component. But keep in mind that, the Earth, every atom on Earth is pulling on whatever you're moving sideways, okay? Keep that in mind. It doesn't go away. And the explanation is qualitative. That's what we're interested in. We're not interested in math, in the numbers. That's all that the mathematicians are interested in. We're interested in the qualitative stuff. We want to understand what the mechanism. Mechanism involves both second law as well as the gravitational equation. That's known as physics. Okay? We need an explanation for what is actually happening in that invisible world. And yeah, you're going to eventually zero in on the mechanism of gravity and realize that it's a pull force, some kind of pull force. And I always say, do this experiment at home, always in the presence of a trained relativist, okay? Just put your arms to your side, okay? And see if you think something is pushing on your arms or you feel like they're pulled downwards by whatever gravity is, okay? And yeah, you'll feel that you're being pulled. It's easier to pull down than it is to pull up, okay? Why? Because you're being pulled from the bottom, okay? Just like two magnets, you don't feel that your hands are being pushed from the outside. You feel that something is already pulling from the inside here. So this magnetism is some kind of pull force. And in a similar way, okay, as an analogy only, if you put your arms to your side, you feel that, oh man, it feels a lot better when it comes down. Why? Because something is pulling, and pull is easier, okay? You're struggling when you pull your arms up. You feel that something is actually pulling from the bottom, not pushing from the top, okay? At least that's my experience. Maybe you can tell me yours. Okay, let's go on with some of the questions people raise, some of the issues. Here we have first one. He talks about the mathematical physics method, okay, Math Viz method. And he says they use careful observation and experimentation to confirm or reject a hypothesis. Okay, I'm not sure what, hypothesis is an assumption. What are you going to confirm? And what if you do confirm? Confirm to whom? To yourself or to whom? To your boss? Evidence against theories and laws are searched for and studied closely. Evidence is what they use for what? To persuade, to convince people. And that's known as religion. So yeah, we don't use evidence in science, but they apparently use it in this mathematical physics method. Okay? And theories, they don't have any theories because math has no theories whatsoever. Math is only a descriptive discipline. They only describe. And Math Viz has attempted to give explanations to some of those equations, and just about every single equation every single explanation related to invisible entities is irrational. Every single one. There's not one that is rational. Why? Because they do it all with particles. And if you do it with particles or waves, which are another way of saying particles, you're not going to be able to explain how Mother Nature runs a shop. Okay, and there are no laws in science. So yeah, math-phys method is deals with laws, whatever those are. Apparently, they've turned all these equations and they call these equations laws. That's what they think God made them or something. Okay, it says based on well-established repeating patterns and regularities in nature. Okay, reproducible results are required of experiments. Well, yeah. Here's a. Let me show you for a second here. Give me a second. I'll do a little experiment. Okay, here's a reproducible result. Okay, I let go of the ball. Okay, falls to the floor. I let go of it again, and again it falls again to the table. Repeatable, done it twice, right? That's repeatable. You want it 3 times? Okay, I'll do it one more time. Okay, okay. So I did the experiment 10 times, 100 times, a million times. Does that mean you can explain what caused the ball to fall down to the floor and not to the ceiling? So no, in science we don't care about what this mathematical method proposes. Reproducible results are not important. In case of failure, no excuses are accepted. Well, yeah. Personal stories or testimonials are not accepted as evidence. That's strange because they introduce observation, and observation has a single purpose, and that's to tell your personal story, okay, your own anecdote. Consistent and interconnected, okay, argues from scientific knowledge. It turns out that we don't know what knowledge is. They never defined a word, so we don't know what they mean when they say knowledge, okay. Knowledge, according to the definition, is justified true belief. There is no difference between knowledge and belief. One person believes that God doesn't exist, the other one knows that God doesn't. And so you figure out which one is correct. And again, you find out that they both believe. Okay, use a vocabulary that is well defined and is in wide usage by co-workers. Okay, first of all, well defined, there's nothing well defined in mathematical physics. You get words like energy. We just found out that Mr. Feynman says he doesn't have the slightest clue what it is. We have 7 definitions of mass. What was it? 4 of weight. They don't know what time is. No one can define the word time in such a way that they can use it consistently and apply it, because they just want to use the numbers in an equation, which has nothing to do with the definition that they put out there. Okay, so they have all these words like wave and so on, and they turn them into physical objects that are not well defined at all. In fact, they're not defined, let alone well. Okay. And then wide usage, that's got to do with democracy. That's raising your hands and saying, oh, we're going to use it here at our club. We're going to use it in our congregation. Well, yeah, so, that doesn't make it right. You can use the flat earth could have wide usage. That doesn't make it so. Okay, so, yeah, it doesn't matter. We don't use democracy. We don't use wide usage. We don't use voting. Okay, none of that applies in science. Convinces by appeal to evidence. Well, again, convince has to do with persuading. We don't convince, we don't persuade, we don't convert, not in science. That's in religion. So you're in the wrong place. And again, evidence is what you use to persuade people to change their opinions. So we don't use evidence whatsoever. Evidence has no place in science. It only has place in religion. It only triggers or targets belief, opinion. Peer review, again, we don't do peer review. The only thing we do is we criticize from the scientific method to see if it's rational. And if it's irrational, for example, if they convert concepts into physical objects and begin to move them around like transferring energy or moving a wave, then we have a problem with that, and that's when it dies. That's the only review we do. Other than that, we don't care about in fact, quite the contrary. We accept all kinds of ideas out there. We allow every person to express his ideas once he passes the rationality part. Okay, he's got to make sure that he doesn't turn concepts such as energy into objects, or vortex into a physical object, or ether into a physical object. None of those things are allowed in science. Okay, but that's the extent of the so-called peer review. It's called challenging the assumptions. Okay, and there are no experts in science. That's known as authority. the only thing I can recommend to all people who follow this mathematical method, they probably should become Catholics and just bow down to the Vatican or whatever. You'll find experts over there. In science, we have no experts. Progresses as time goes on, more and more is learned. Well, obviously that doesn't apply to mathematical physics because the math-phys method, they haven't learned anything, for example, about gravity in the last 400 years, not one bit. They haven't learned anything whatsoever about electricity. They haven't learned anything whatsoever about magnetism or the workings of the atom. So we don't know what they learned. They learned absolutely nothing right now. They have only irrational explanations. And if they have irrational explanations, what can we say that they learned? I mean, they haven't learned anything, absolutely nothing. And I'm not exaggerating here. The invisible world is totally unknown. Or like Mr. Feynman said, I wish I would have put that up there. He said, we don't understand anything. We cannot explain anything of, especially, the quantum world, the world that the unseen, the world of the unseen, untouchable. They don't understand that because, again, they don't deal with objects. They deal with equations. They can describe what's going on there with the visible stuff, and they imagine it's mediated by particles, right, or concepts, but they don't really know what's going on. They cannot explain to you a mechanism. They cannot give you a physical interpretation. Okay, here we have St. Fellow says pseudoscience. He says mathematical physics falls under this pseudoscience, I guess. He says, starts with a hypothesis, looks only for evidence. Yeah, I guess that qualifies as pseudoscience. When you look for evidence, you're talking about really religion. You could call it pseudoscience, fine, no problem. Little or no experimentation. Yeah, we don't do experiments in science, so I guess if you do any kind of experimentation, you're doing pseudoscience. Experimentation, the only reason for experiments is to convince yourself of something and to convince someone else of something. In science, we don't care about that. We care that you give us an explanation of how the invisible world of Mother Nature works. That's what the purpose of science is. If you can do it with experiments, if you can do it by having a bad dream at night, we don't care. We don't care how you got to that. We just want the explanation. Okay, we want you to give us a rational explanation of how Mother Nature does gravity, magnetism, electricity, workings of the atom, etc. Conflicting evidence is ignored. Again, we don't use evidence in science, so anyone who uses evidence is doing pseudoscience in any way, shape, or form. Personal stories or testimonials are relied upon for evidence. Yeah, I guess that's what it is. Anyone who relies upon for evidence is doing, again, religion. Okay, and yeah, personal stories because they introduce the observer, and they constantly say, well, we observed this. That's how they start. They say, we observed this in the lab. And yeah, that amounts to a testimonial. We don't care what you observe. In fact, they're observing invisible stuff. They're saying they observed one particle at two places at once. They observe Big Bang. They observe all this stuff. And, and those are personal stories. Those are testimonials. Argues from ignorance? Absolutely. Pseudoscience argues from ignorance, and that's mathematical physics right there, because they claim they know nothing. Okay? They have no explanations for how this universe works. Okay? Lack of scientific explanation is used to support ideas. Absolutely. No scientific explanation. No rational explanation. Use especially invented terms that are vague. Yeah, they use like energy, mass, time, field, wave. They use words like that. Ether, vortex, they have a charge. They have all these words out there that they invented that have no meaning. They're all concepts, and they're treated as physical objects. So not only are they vague, but they're irrational, completely irrational. Attempts to persuade? Absolutely. That's what pseudoscience does. Anything related to persuasion, convincing, recruiting, that's called religion. No peer review with checks or verification. Yeah, again, in science we have no peer review. Pseudoscience, I don't know. I don't know if the monks, check each other out. I don't know. That's something that math phys has to answer. And no progress. Nothing new is learned as time passes. Absolutely. Mathematical physics, nothing has been learned through mathematical physics in the last 400 years since Newton, Galileo, and so on. What have we learned? I mean, what can they explain? Is warpage of time an explanation for gravity, which is the official version? Is a particle at two places at once, is that an explanation for what's happening in the quantum world? Is that a rational explanation? So if those are irrational explanations are very clear cut, that any rational person should look at that and say, well, this is absurd, well, then what have we learned? What can these people explain to you? Especially when Mr. Feynman says, and he's a guru, he's a Nobel Prize winner, he's revered by all these mechanics, right? If he tells you that we have no explanation, we've given up on explaining, meaning mathematical physics, right? Physicists. They've given up on explaining, on giving you physical interpretations for what's going on in that invisible, intangible world of Mother Nature's. Okay, here we have another fellow. He says, here we have, in fact, an example. It says, energy is change over time. Yeah, the only thing this fellow has to answer is, how do you transfer change? I mean, do you carry it with your hands? Do you pick it up with tweezers? How do you transfer change? That's the only thing he's got to answer. So if that's what energy is, well, all you got to do is explain how you transfer it. Okay, no mathematical equations. We want to see a physical interpretation for the transfer of energy. What did you do? Okay. Another fellow says unfalsifiable means there is no way to test it to know whether it is true or false. Well, true or false are opinions. So again, unfalsifiability, Popper's criteria, right, for science, is absolute nonsense, because that has to do with belief. It has nothing to do with science. It has to do wholly, 150% with religion. It has to do with opinion. I mean, is God true or false? I mean, period. I mean, that's what you got to put there. And if you have your opinion, I have my opinion, well, then we have no unfalsifiability. We have no way of falsifying whatever you propose, okay? So yeah, we don't care, because even if you have a way of falsifying it, all you did was give us your opinion. You say, oh, I can falsify this. Okay, yeah, if you falsify it, you did it to yourself. Maybe the Pope has a different opinion on whether you falsified God, or the angels or whatever, or space-time. Okay, here we have another fellow. He says, in the tension of gravity, Newton's equation, what does G represent? Gravitational constant G, okay? This is the value that has been calculated for more than 200 years, yeah? Seeking and researching accuracy and precision. However, there is still no explanation for how it works. This number, what does it represent? What does it mean? Okay, this is beyond the scope of YouTube. I have explained it in my book, in quite a bit of detail, in fact. So all I can tell you is, if you get a hold of my book from a friend or whatever, well, then you'll see it there, okay? It's too lengthy to present here, okay? So yeah, I do have an explanation for what that number in the units represent. I think I explained that in quite a bit of detail. I don't think you can explain it in more detail than that. So all I can do is tell you, go look at the book. Not that I'm trying to sell you a book. I'm just saying that's where I put it, okay? And that's too complicated to explain here. Sorry. So you'll have to take a rain check from me on that one. Fellow says, why don't the ropes get knotted together? Okay. Well, they don't get knotted together first because he's got the wrong criterion. Okay. Object is not that which you can see or touch. Okay. So that's what he wants, touch. He's talking about touch there. Okay. No, that's not what an object is. A rope is an object because it has shape. Okay. Do you see the shape? You see something there. Hopefully, in front of my nose there. Okay. Okay, so you should be able to figure that one out. The criterion that you're choosing is what's wrong, okay, what's irrational. Because if we tell you that the rope cannot be seen or touched, that it's a fundamental, that the thread that makes up the rope is a fundamental entity that cannot be seen or touched, it's nonsense to say, why can't two ropes touch each other? Well, because they cannot be seen or touched. What part don't you understand? Why can't you see the air? I mean, that's the same question. Why can't see the air? Well, why can't you see the air? God didn't give me the right eyes, I guess. Why can't you touch the moon? I mean, I can't touch the moon. Maybe if I were an astronaut, I could go out there, but I can't touch the moon. So does that mean that we have a problem, that the moon is not an object because of that? Because I can't touch it? In fact, I don't know. Some people might ask, why can't you touch that table on the other side of the planet? Well, because, it's just not available to me. That's why. And this is more or less the same thing. You say, well, no, but here we have them touching. Well, for that, you got to come up with the word touch. You need to know what the word touch means. You haven't given us a definition of the word touch. And I'm sure I can destroy whatever definition you put up there. So I'll wait for your definition of touch. How's that? Is that a fair game? Okay, I'll take the challenge. You define touch, and I'll tell you why they avoid touching, getting nodded. Okay, and final issue: singularity does mean it. Singularity does mean it came from nothing. Doesn't mean, I guess he meant to say, we can't trace back before that. He's talking about the Big Bang. Big Bang does not say everything came from nothing, and that's the big problem. That is the fatal problem with Big Bang. Because the Big Bang says we can go no further than the Big Bang. And that's the problem, because where did the matter come from? Where did space come from? Specifically space. Forget about matter. Matter is easy to create. The issue, how do you create space? How do you create nothing? That's what the challenge is. And so what these people are saying is suddenly there was an explosion. Explosion of what? Because you need to have a foundation. You have to have a hypothesis. You have to have something before it explodes. And these people are trying to sell you a whopper. They say there was nothing, which is what space is, and suddenly it created space. So there was space, and you created space from absolutely space. Nothing. Void. Vacuum. That's what they're saying. So Big Bang is for people who, with tiny brains who accept this nonsense as a physical interpretation. Okay? What they've done is simply rewind the clock back. And they said, look, if galaxies are all going away from each other, in the past they were closer together. That's what they do. That's what Big Bang is all about. And so what are they saying? Well, they say if you wind the tape all the way to the beginning, at some point, 13.7, 13.8 billion years ago, you end up with a singularity. What's a singularity? It's a mathematical nonsense called zero, nothing, zero volume. Of what? In what? They say it's space that suddenly got created. Space got created. From what? Well, we can't go that far. Well, then you don't have a rational theory. We won't accept your theory until you can explain that point. You have to explain that point. You can't elude it. You can't say, well, that's unscientific because we weren't there. We didn't see God make the singularity or whatever. You have to explain, because that's what we want to know. We want to know the origin of matter and the origin of space, which is what supposedly the Big Bang created. From what? What was there before? Of course you need to put that before in there. You can't elude that. That's the fatal problem with Big Bang. You can't elude the question. Okay, with that, I'll see you next time, and that's going to be, I guess, on Sunday. Am I right? No, I'm going to see you on Wednesday. We'll see you then. Bye-bye.